Okay guys, so you did Ohm's law yesterday, which if you remember is E equals I times R. So hopefully that all makes sense because we're going to go one step further today and do the power equation. And so the power equation, computer will work. There we go. Okay, so the power equation defines the relationship between watts, amps, and volts. So Ohm's law was volts, amps, and ohms. Power equation is watts, amps, and volts, which if you think about it makes sense. Watts is measuring how much power is being produced. So power equation is really useful in determining how large you should make a circuit, which we'll get to later after Christmas break, but really helpful into figuring out the size of the circuit in terms of like 120 volts, 220 volts, that kind of thing. Also wire size that you should use for electrical projects, and then also the circuit breaker or fuse size that you use, which helps in terms of safety. So the power equation, P is for power, which is your watts. I, just like yesterday with Ohm's law, is your amps. And then also like yesterday, E is that electromotive force, or your volts. So the power equation is pretty simple. It's P equals I times E, or if you think about it, pi. So your power is equal to your amps times your volts. So pretty simple. Today is going to be real quick. Here's the sample problem. So assume that 0.83 amps of current flows through a 120 volt circuit. How many watts of electrical power are being used? So you're looking for watts, and so you have that P equals I times E. So if I is 0.83 and E is 120, simply just take those two together, multiply them, and you're going to get 99.6, or if you round it to the next watt, it would be 100 watts of power. Okay, another practice problem. Assume that there are 5 100 watt light bulbs being operated on a 115 volt circuit. How many amps of current are flowing through the circuit? So this big thing is important to read. So you're probably going to look and just say, oh, this is 100 watts, 115 volts. Well, then you're going to get it wrong. There's 5 100 watt light bulbs, so you're going to take 5 times 100. So you have 500 watts, 115 volts. And so then if you think about that equation again, you have P equals I times E. So you can kind of do the same thing. We usually do the power equation in a square. So take your square, divide a line in the middle, hot dog style, horizontally. So on that top half of your square, put a P, and then your bottom half, divide it in 2 quarters, and then you have an I and an E. So if we're looking for I, you cover up the I, you have P divided by E, so your 500 watts divided by 115, and you're going to get 4.35 amps. Okay, one more thing. So then you're assuming that there is a 1200 watt coffee pot pulling 10 amps. You're trying to figure out the source of voltage for that coffee pot. So again, think of P equals I times E. You know your P is 1200, your I is 10. You're looking for that E or volts. So you're going to do that. Cover up the E, you have P over I. So you're going to do 1200 divided by 10, which should give you 120 volts. Okay, just talking real briefly, determining wire size and circuit breaker or fuse size. This is important because you want to figure out the appliances that you can use in a certain circuit. If you've ever had multiple crock pots or roasters plugged in and it flips a circuit or a breaker, it's probably because it's not too much voltage or watts going on. So it's also important because of the voltage source and then the wattage rating for certain things. And so the power equation is really helpful in determining all of that. And we're going to skip all of this. Alright, so that's where we're going to stop for today. And then I'll get you a new video for tomorrow to finish up the week.